All right, quickly, a couple takeaways from this 100 foot-pound, 9 millimeter paintball trigger PCP. Um, let's see. For one, originally I had mentioned in the old videos that I would take this trigger guard off and shorten the trigger. It turns out this isn't like a drop sear mechanism, and the length of the trigger is key to the force required to, unleash the hammer. So this provides a lot of leverage. If I shortened it and replaced the trigger guard, the trigger would become heavy, and right now it's not. But I will say these trigger units are super easy to use on a build. Unlike a Crossman, the safety stuff doesn't pop out, when you take it off the frame. So this just pops in and out, no problem, and everything stays together. Um, as far as the stock, yes, it's a pretty simple design. Wire stocks, anybody can make them as long as you have a couple taps and drills and let me think what else, and a vise in order to bend the wire up and stuff. Um, But the only downside to it is that that metal plate, when you're shooting something with 100 foot-pounds, I have some bruising on my shoulder from shooting it outside the other day. So maybe 100 foot-pounds wouldn't normally cause anything. I mean, that's like 22 rimfire power. But the bigger the bore, the more the recoil, and then you got a metal plate up against your shoulder. So some padding on that would definitely help. As far as the mechanism, that's the most important part. The side lever itself should have been longer. It should have been at least like an inch or an inch and a half longer. If you look at like the Bulldog, the Hatson pile driver, there's a few other examples. Anything with a conventional valve where you have to deliver a serious blow from the hammer, you'd want a longer lever because, this distance from the fulcrum, and I'm going to talk about that fulcrum point, the distance from the fulcrum is going to determine the effort required to cock the gun, to move that heavy spring. And hopefully I'll get a chance to talk about the math that I did involve in the hammer stroke. But so this is the fulcrum point, and it's at about the right distance. Um, for the leverage. I mean, for this, it's not that hard to charge it. But everything should have been longer, including the hammer path and the arc of the arc of the side lever would have been longer too. Obviously, if the handle was like up here. And so anyway, what I did was I plugged in some numbers. Force equals mass times acceleration, and one of the factors in that is the stroke distance. So in this case with the spring, my stroke distance was barely an inch in this configuration. And yes, I shortened the valve stem and stuff like that. I made all kinds of adjustments just to get to 100 foot-pounds. So anyway, I plugged in the 1 inch, and my foot-pounds of hammer energy with a 54-pound spring were something like 4.9 foot-pounds of energy to open that valve. So then, without changing any other numbers, I kept the hammer weight the same, I kept the spring the same, and I plugged in 2 inches of stroke. And the force went up to something like 8.9 or 9 point something foot-pounds of energy. Not quite double, but it was a huge gain in your impact on the valve stem. And generally, with a conventional valve, and what I mean by that is a hammer valve that's not balanced in any way, you're going to need a lot of hammer energy to open the valve. So if you can get it, you can get it two different ways. Because remember, you're always trading. You're trading work for distance with torque and horsepower, and kind of the same general rules apply here, as opposed to having a super heavy spring that's 2 inches long to create the energy. It's actually nicer to have a 4 inch spring that's lighter, but you increase the stroke length to make up for it. So I would have preferred a stroke length design as opposed to a compact, 54-pound spring to generate the force. And then another thing that, might cross your mind, and yes, that's just from my dirty hands. I like the off-white, but my hands are just consistently too dirty to even handle it. Another thing that came to my attention is that when you're working with a monoblock, and that's what this would be called, this main block is what it looks like. When you're working with a monoblock design, you have certain constraints to your flow. So a gun like this with a 20-inch barrel, 9mm, you might assume, well, then it should flow as good as, let's say a Benjamin Bulldog and get like 160 foot-pounds right out of the box. And that's true and false. Yes, it can be done with a bigger monoblock and less choke points. The reason this has choke points, which I didn't think of at the onset of the build, is that, well, the hydrostatic pressure. So I only had a 1-inch, I think this is actually 25mm width of the block. So the biggest hole I could put in there for the valve was roughly 15mm to be tapped by M16. And in order to make that connection from the air tube to the block strong enough, I can't go through the center, with a 308 or 5/16 bit or 375 bit. I'd be losing wall thickness. And because those walls also house O-rings to seal the thing, it gets even worse, because an O-ring might be shy of the major thread diameter by a whole millimeter, sometimes 2, sometimes even 3. So you're going from, let's say, M16 to 1 threads. Now you're going to the O-ring thickness, let's say, is 14mm or 0.550, and then you're trying to drill that to, the largest flow rate possible. And, the numbers keep dwindling as to what you can use and still have something that'll hold together at 4,000 psi or so. This thing, I filled it to 4,700 for testing. But my confidence wasn't there. I mean, it was a hydrostatic test with non-compressible fluids. So, but even at that, I was like, oh man, this thing might give way, but it didn't, and it's holding up fine. Mostly right at that connection, that first connection, the front connection with the 1/4-inch dowel. I did the math on that, and it's actually even at 3,700 psi, it was at like a 2.5 to 1 safety factor. So that wasn't my concern. It was this rear one, A, the manner in which it was mounted to the block, and B, the manner in which it was pinned so close to the rear of the tube. But there was no measurable elongation, after the hydro test and stuff. So, but anyway, at 3,000, which is a much lower pressure, it's perfectly reliable and stuff. But I still had that choke point where I was trying to feed, like a 5/16 transfer port through a 1/4-inch hole. And that's just impossible. If you only have a 1/4-inch hole feeding into the valve, then your maximum transfer port diameter should also be roughly a 1/4 inch. I mean, you have to subtract the stem area and stuff like that, but they're intertwined directly. You can't flow maximum pressure through a larger bore over here than you have over here. Once you have a choke point like that, there's a good video explaining more of that on the Umarex Notos, which has a built-in choke point, which I never understood. And one person that I was talking to under the video, they drilled theirs out like another millimeter or two, and they gained 50 FPS with no other mods. So, but the choke point, I couldn't go around it because I started with this 25mm block. If I had started with, let's say an 1.5-inch wide block, I could have went huge. I could have went with a bigger air tube. The connection therefore would have been bigger. I could have had a 1/2-inch hole going through. And so the valve would have limitless air. Well, not limitless, but enough. This tube is 100 cc's. Figure the valve maybe is another 10 or something. So it's like a 115 cc gun. But yeah, if I was going to do this design again, I might use maybe a better looking pistol configuration. Ideally, though, if you're going to do something with a heavy hammer spring hitting a conventional valve, you have to retain that hammer. The way to do it is a drop sear. And if you haven't seen how like a drop sear works, or you don't even know what I'm talking about, you can check the 50 caliber pistol build. I had to build the pistol grip and the trigger system all from scratch, and that had a drop sear, and it was very effective. I forget how much weight it was holding back, like 30 pounds of force or something, but it felt like it might as well have been holding a gram. I mean, it doesn't make a difference. You know, the drop sear forces, they don't translate to your trigger pull. So if you took like a Marauder rifle trigger group and loaded it up to 50 pounds, which by the way I've done, you cannot differentiate. If you were blindfolded, you would have no clue how much weight was loaded on the trigger mechanism. It's actually, brilliant engineering. The Marauder, well, any drop sear is brilliant engineering. So yeah, I mean, there's the two major things would have been, the hammer path stroke, which was limited in this configuration by a couple different things. I made some tweaks to improve it, like let's say the valve stem is here and I couldn't go, I couldn't do anything further in that channel as far as machining. So I recessed the front of the hammer with a 45-degree bit about 4 millimeters, so the hammer would still travel further before impacting the valve stem. The side lever, would be, if I was doing it again, I'd do it like 2 inches longer. Just make it overkill. You're trading distance for effort. The distance is the arc, that this would travel, and the effort being the force that you're perceiving. The other thing, oh, this is a big one. The other thing, someone really smart in the comments pointed this out, that this intersection where the pin goes between, we'll call this a pawl, and the side lever, it needs to be at least as far out as the rear connection, the center line of the bolt path. And if it's not, it blows open. So I had to do some modifications here and spread these arms so there's a friction fit. But really how it should be is that this pin path is beyond the center line of the bolt path. And when that happens, so it'll push down, and it would keep going. And this arm would actually be angled downward. So not only would this not blow open, but you'd have cam over. In other words, the lever would contribute to the bolt staying in place. Whereas now the lever, aside from the weight of it and friction, contributes nothing to the bolt staying forward. It works, because I modified it after the fact, because you see that it takes a little force to shut it. It'll stay there. I've shot it at least 50 times now. It'll stay there, but it's not the right configuration. Those little two tongues, with the hole in them, that connection point should be further into the or beyond the center line of the bolt path. And what else? Could I tune it now to get up to like 120 foot-pounds, let's say? I probably could, but I'd have to remake this connection, degas the thing, take it completely apart. I'd have to open up my transfer port on the barrel. I'd have to make a new one for this connection and design it around the idea of having a 308 5/16 through hole. So it would be a lot of work, and I don't have any deer or hogs or coyotes in my backyard, so 100 foot-pounds is enough for the the plinking I'm gonna do. As far as the paint, I don't know how durable it would be. I might put a couple coats of clear on there, and the clear is more durable than the paint itself. And it's flat clear, which would, flatten this effect here. But then again, the gun's probably going to spend the rest of its life hanging on a hook in the garage. It might not be used too much. Although I do like the gun, I like shooting it, but I'll be working on other stuff and I won't really have time to be shooting it. But anyway, I hope that clarifies any, questions about, where, when, how, and why I, put this thing together. And I think, a lot of, well, at least the subscribers, they get the general idea. I'm building this type of stuff for kicks anyway. So why not post it on YouTube? Maybe somebody else will build something cool. But yeah, I've been building different types of air guns for years now. I probably built hundreds of them. Sometimes I'll look in a drawer and find one that I don't even remember building. So it's just like, it's a hobby. Just I'll be laying in bed and think of something new and, try to figure out if I can make it and then how to make it and then start ordering materials. And I was doing this before I ever recorded it. So I figured I might as well, share it to whatever extent I can. All right, well, that's about it. Thanks for watching.